Everybody, I want to do one more example in this section, kind of going backwards this time, starting with the degree, starting with the graph, excuse me, and then trying to pull out information about the equation, the degree, the zeros, etc. So this is one of your your homework questions, the last one on section 3.2. And we have a picture of the graph. So the graph to the right is a complete graph. So they're telling you that they're showing you enough of the graph where you can see the end behavior. It's continuous and displays the function's end behavior. All zeros are integers. Answer the following questions. So we want to list the zeros whose multiplicity is even. Now, if I look at this graph, let me see if I can blow it up a little bit here. I do see zeros. So I see 1 0 here, 1 here, and 1 here, right? Any place that we have an x-intercept is a real zero. Now, remember for multiplicity, if your multiplicity is even, that means that at that zero, you're not crossing the axis, you're only touching it and you're turning around. We only cross the axis when we have odd multiplicity. If I look at all my zeros again, I see I cross the axis here, I cross it here, and I cross it here. So there are no zeros that have even multiplicity. And remember, you may get a different graph, right? So I'm doing my example. List the zeros whose multiplicity is odd. So I do have 3, right? All of these are going to be odd because we're crossing the x-axis. So here I'm at what? -2. This is at +2. And then let's see, 1, 2, 3, 4, 5. And this looks like 5. It did say to put commas between our answers. And like I've said before, if they're asking for zeros, they typically just want the answer. They don't want you to write points or x equals or anything like that in general. So write an equation expressed as the product of factors of a polynomial that the graph might represent. Use a coefficient or 1 or -1 and make the degree as small as possible. Now, we haven't really seen an example like this where we've had to work backwards, but I want you to think about what you know here. So first of all, I know I have 3 zeros, right? And I know when solving an equation, I would have to get these as answers. So think about working backwards, and I'm going to kind of keep tweaking this. So let's see, my zeros are -2, 2, and 5. So in order to get an answer of -2, I would have to have a factor that was x plus 2. Because when I set it equal to 0, I would be subtracting 2 to both sides. To get an answer of +2, I'd have to have a factor that was x minus 2, right? Because when I was solving, I would add 2 to both sides. And then my last factor would be x minus 5, because I know one of my answers is +5, right? So you have to think backwards here and think, okay, if I was solving, what would it look like so I get the answer that I want? And basically, you just switch the sign in the middle so that when you solve, you have the correct operation there. Think about some other things. Notice here that I have 1, 2 turning points, right? So if I have 2 turning points, my degree could be 3. It could be more than 3, but it could be 3, right? So that would make sense here. I have 1, 2, 3 zeros. So it looks like it's on track. I'm also going to think about my end behavior. I notice the left side goes down and the right side goes up. So my degree should be odd. So I'm kind of guessing that my degree is probably 3 here. I don't have the exact answer, but that seems to be working out. I have 3 zeros. I have the right number of turning points. The end behavior seems to match. So I don't think I need to add any exponents here on any of my values because I have 1, 2, 3 answers. It seems like it's right. All of our values cross through the axis. So my exponents would have to be odd anyway, right? So I'm going to leave them as 1s. If I had an x value or a 0 that touched the axis and bounced back up, then I would have to put in a degree of at least 2 on that little part, or an exponent of 2, because I need to make it an even multiplicity. Here I just have it odd. The last thing they want us to do is to use a leading coefficient of 1 or -1. So this is the end behavior. Well, the left side goes down and the right side goes up. So if you think back to your chart, that happens for odd degree when your leading coefficient is positive. So I'm going to leave it as a 1 here, or I guess I can leave it out, but we'll just put it in as 1. So I'm making this a puzzle. Think of it like a puzzle. Look at what you know in the graph, find your zeros. Think about the multiplicity of those zeros. Are you crossing the axis or are you bouncing back up, right? One is odd, one would be even. And then look at your end behavior. So to figure out if that leading coefficient should be positive or negative. All right. And what is the y-intercept of the graph? Type an integer or simplified fraction. So here, let's see, looks like it's 0, 2. I zoom in there. Oh, maybe I typed it in wrong. All right, but I figured out what I was doing wrong. And I was thinking about cutting it out of the video, but I thought to myself, you know what? I'm going to leave it in to show that even I rush and I don't pay attention. So notice here, I was saying, what is wrong? I know this is the number 2. I'm losing my mind. And then I thought to myself, I zoomed in that graph a lot. Maybe I'm not looking at the scaling. So after I zoomed in, I couldn't see the bottom of the graph. And if I scroll down, I see that on the x-axis, the scaling is by 1s. But on the y-axis, the scaling is by 10s. So this is not 2, it's actually 20. So I'm going to leave that in the video to show you that, I make mistakes sometimes too, or I rush. And when I zoomed in on the graph, I hid my scaling on the bottom and didn't even realize it. And I'm sitting there going, why am I getting this wrong? I know how to find a y-intercept. So be careful. We all make those mistakes. When I zoomed in, I hid the bottom of my graph and I didn't realize that my scaling was not by 1s on my y-axis. So that's the last part there. My answer would just be 20 in that case. So I hope this helps you on your question. Again, I wanted to throw one of these in because, we do stuff like this. We look at the graph first and try to work and find the model. So it is helpful to be able to pick up those key information and pieces like that and really think of it like a puzzle. What you can also do too as you're going through is you can also maybe use Desmos to help you, like graph your equation and see if it's kind of matching the one that you're looking at. And that could be a nice tool as well.